In this video, I will explain how to conduct chi-square test using Microsoft Excel and RStudio. Chi-square test of independence is used when we have two nominal or categorical variables, and it's a type of relationship test, which means we want to see if there is a relationship between them or not. And for this purpose in Microsoft Excel, for example, one of our categorical variable is gender, and other categorical variable is opinion of people, whether the current government can reduce the deficit or it would increase the deficit, or if they do not have any opinion. So these are our two categorical variables, and data is presented in a contingency table. A contingency table is the one that summarizes categorical data in a table. So this is the count of frequency of responses, and this is called contingency table. Our null hypothesis is that there is no relationship between gender and opinion of people. And alternative hypothesis would be exactly the reverse, which means there is a relationship between gender and opinion. And at the core of chi-square test is a comparison of observed values and expected values. So from these values we will develop expected values, that what values we are expecting. In order to calculate expected values, I will copy paste these values and I will paste them only as values. Okay, in the next step we need to remove these values and leave values on the margin as such, and next we will make a formula here, and in that formula we will use the value, terminal value in the column, this value that will be multiplied by the terminal value in the row, and that will be divided by total. So that's a formula. Now we need to apply the same formula in other cells as well, and for that purpose we can do it manually or we can also drag it. But if we drag it, we need to make a smart use of F4 key, and for that purpose what we do here is that let's say for example this one at 292 that is using this value, and so we will lock this column, that's the cell number of 549. So in 249 it's B11 and we want to lock it. So for that purpose I will, if you press F4 one time it's absolutely locked, and if you press it two times then only this column is locked. And for E9 we need to lock this row. E9 represents this row, and in order to lock this one I will press F4 key 3 times, and when $sign appears in the beginning it means the row is locked. And for E11 that represents the total, I will press F4 key only one, and you see $2 signs appear. Now in this one by using this thing we have you can see that this one B11 which is showing a $sign in the middle of B and 11, it means this column is locked, and this was achieved by pressing F4 key 3 times. And then E9 which represents this row, that's 506, $sign appears up front in the beginning, and it was achieved by pressing F4 key 3 times. I will do it one more time. So when I press it one time all $signs are gone. If I press it one time there are $signs. I press it second time, column is locked, and if I press it third time $signs appear in the beginning, and which means row is locked. And now we can drag it in this way and also in this way. When you compare the upper table, that's observed values table, with the expected values table, you will see that total remains the same. Total that appears in the margin of the table, that remains same, 549 308 93, and the same thing is here, 549 308 93, and similarly total in both columns, that also remains same. Only values in the body of the table, they change. So for instance, while the observed value for female who believed that the current government would reduce the deficit is 244, and the expected value was 292. And similarly, in case of males who think that current government can reduce the deficit is 305, while the expected was 257. Chi-square test is essentially about a comparison of these two tables, that's observed values and expected values. To calculate chi-square test and probability value, we will need two main formulas, and one of them is for probability value, and for that we'll use this formula chi-square test and actual range and expected range. Actual range appears in blue table and expected range appears in green table. And the next one will be chi-square computed and then chi-square critical, and for that we will use this formula chi-square INVRT and probability value and degree of freedom. When we will be calculating chi-square computed, we'll be using our probability value that will be coming from this one, and when we will calculate chi-square critical, we will be using our significance level or alpha level or risk level, that's 5%, and degree of freedom would remain same. We will also be using some other formulas, but they will be meant to support these two syntax. Significance level or level of risk is 5%, degree of freedom is 2, and degree of freedom is calculated by using this formula, that's number of rows minus 1 multiplied by number of columns minus 1. There are two rows, male and female, 2 minus 1 is equal to 1, and column, there are three columns, and 3 minus 1 is 2, 2 multiplied by 1 is 2, and for probability value we will use this syntax chi-square test, and it's asking us actual range and expected range. This is actual range, only values in the body of the table, and the same thing for expected, only values in the table, and that gives us this probability value. I will convert it, this scientific notation, to number, and so p-value is really very small, and then chi-square computed is equal to chi-square INVRT, and it's asking probability because it's computed, so we will use our calculated probability value and this degree of freedom. And now chi-square critical, again we will use the same formula, chi-square INVRT, and for this probability we'll be using the significance level, that's the only difference, this one multiplied by degree of freedom, and chi-square critical is 5.99. Now the next thing is to interpret results. As you can see here, there are two ways. First thing is that we compare chi-square computed with the critical one. When chi-square computed is greater than critical one, then we reject the null hypothesis. Or a more easier way, the more consistent way with the one that we have already done in the past, is that we just compare this one with the 5% probability value, because this value is lower than 5%, 0.05, so we reject the null hypothesis, and our null hypothesis was that these two categorical variables, that's gender and their opinion, they are not related. So we reject this hypothesis and we say that gender and opinions are related to each other. To conduct chi-square test in RStudio, first important thing is format of data. RStudio can deal with different formats of data. So for example, if data is raw data, unsummarized data, RStudio can deal with it. And alternatively, if data is summarized or is in a contingency table, just like we had in Microsoft Excel, so this is the data that is in contingency table. If data is in contingency table, R can also deal with that. So that's one of the strong feature of RStudio, that it can deal with both types of data, in contingency table and raw data, unsummarized one. And let's first we start with data that's in a contingency table. And for that, what we do is that the first step is to make a matrix. And these are the values that I have written, and these are the same values. That's 244, 194, 68, 305, 114, and 25. They are written there. And syntax is matrix C and these values. Now I will add several other commands to this syntax to convert this matrix into a beautiful table, and we will be doing it one by one, and I'll be showing you how it looks like. So for instance, let's say with this one, this is highly raw format, and if I want to see how it looks like, I will just enter here chi0 and I will run it, and it gives us this matrix which is very raw and in an ugly format. To convert this one into a beautiful table, the first thing I will do is that we specify that this data is in row, because that's exactly what we did. I mean, we copied this data from a row. For example, over here it's 244, 194, at 68, and then we go to the next row, 305, 114. So we mention here by row, and we say true, and then number of rows, that's equal to 2, because there are only 2 rows. One represents male and other represents female. And when I run this command and I want to see how my table looks like, and it shows this one, that's much better than the previous version. Now the next thing we need to do is that we need to add labels for columns and for rows. In the next step, I will give names to rows and columns, and for that we use this command row names and chi0. Chi0 is the name of the object that I created, is equal to row, and for this one row names, and then we will the first one is female in our, and the next one is male. And let me run this command and see how it looks like now. Okay, so this one appears, although it also shows the other one, which I have not yet entered because I had entered this command earlier. So to enter column names, we will use this command, call names chi0, that's the object, and for that and the name of our columns are, let's say I use short expressions. Reduce is increases, and no opinion. And I run this command and I want to see how it looks like. Chi0, and here you can see everything is there. That's exactly the same table we had in Microsoft Excel. can see this one, female and male, reduces, increases, no opinion, and all these values, they are also the same, 244, 194, like that. And once this contingency table is formed, now the next step is to just use syntax for chi-square test. The syntax for chi-square test is chi-square test and then name of the object, and that gives us these results, and you can see that these results are identical to the one that we had obtained in Microsoft Excel. Here 43.578, and it was also like so this is the one, 43.578, and then degree of freedom is 2 and p-value is less than 5. Now we can go a few further steps to get more information from this one, and the first thing is that we need to store these results in a new object, and for that what I will do is that I will create a new object that's result res, and then chi-square test. I would say a result is equal to chi-square test chi0, and it gives us the same results. And now I will result and control enter, and it gives exactly the same thing. Now the next thing is that to get more information, I want to see what other attributes are there, and for that purpose I will give a command attributes result, which means I want to see what additional information is stored in result. And when I run this command, it says that this is a spelling mistake. So in it says that we have these variables stored. For example, observed, that's already there, we already have it here, but in addition it also has expected results stored there, and expected result is the one that we have here in Excel in a green table. So let's see what are those results. So for that we use this command result $, and then expected, and when you run this command it gives us this expected results, and these expected results again are the same as we had obtained in Microsoft Excel. That's 292, 164, 50, 256, and 144 and 43. I would repeat this syntax how to do chi-square test in RStudio. First of all, we will create a matrix, and this is matrix, and then C combine and values, and after that we will specify that we have entered data by rows, and then we'll mention number of rows, and then afterward we'll be mentioning we will be labeling it row names and column names, and we'll be using this syntax, that row name and the name of object, and the same thing for column names. And then for chi-square test, syntax is very easy, chi-square test and the name of object. If we are able to store this in a separate object, let's say a result, then we can get additional information. For example, attributes, it will tell us that what's stored, and then by using a result $expected, it will also give you expected values. In any case, the interpretation is the same that we did earlier, that because p-value was less than 5%, so we reject the null hypothesis that stated that there is no relationship between gender and their opinion, and we reject null in the favor of alternative hypothesis. Now the next thing is that if we are given data for chi-square test in raw form, rather than in a contingency table, then how to deal with that? So RStudio can deal with this raw data. RStudio can also deal with data that's given in contingency table. We will make a matrix manually and we will label it, and RStudio will also deal with this one. But in Microsoft Excel, if we are given this raw data, then we need to convert it into a contingency table, and for that purpose we can use a pivot table. So here's the pivot table, and in pivot table, let's say this is table range, and let's say I want my results here. Then what we can do is that first of all, let me also give you a brief introduction about this data. This data has been taken from the website of Jim Frost, and he collected this data about a movie, that's Star Wars, and in Star Wars he wanted to determine if there is a relationship between the shirt color of actors and whether they would remain alive or they would die. So one categorical variable here is whether they would be dead or alive, and the other categorical or nominal variable is their shirt color, that's blue, gold and red in that Star Wars movie. So using his data, so for example, let's say if we say about life, I drag life here, and also I drag life in the opposite column, and then color as a subset of row. Now over here we have got this thing. So for example, it shows that let me also, or I can move color up, and so let's say here, so for example here in blue and alive 129, so blue and alive, that's 129, and blue and dead is 7, and for gold alive 46 and dead will be 9, and for red dead is 24 and alive is 215. So using this pivot function table, we have created this contingency table from this raw data, and the next step is easy and it's same. That's we know that this table, it will be our observed values, and the next thing would be to find expected values. And for expected values, first of all, we will also take their sum here and sum this one, and then we will copy this column and paste on the values paste in another table, and then that will be our expected value. And then we will use those syntax, that's probability value and chi-square invrt function to compute chi-square test values. This is the raw data that we will be using to compute chi-square test value in RStudio. And you see here we have two main variables. One is life and color, and both are categorical variables, and there is no contingency table. You don't see here any number counts, and it just tells that observation. And here we have like only two in life variable, it's only dead and alive. In color there are three colors, blue and yellow and red and gold. And so when we do it in RStudio, the first thing is that I have created this object, that's sky1, I import file, and the next thing is that I attached this file. And as I mentioned earlier, that one of the advantage of attaching file is that you don't have to mention here the name of the file. What's the name of the file? There's no need. And then for chi-square test, we just mention the name of variables, and when you run the command, then it gives this result. That's chi-squared value is 6.18 and p-value is less than 5%. So null hypothesis in our case was that, in this case was that there is no relationship between uniform color and depth. But we see that and alternative hypothesis is that there is a relationship between depth or between depth and shirt color. So we reject a null hypothesis and in the favor of alternative hypothesis. We can also get more information from chi-square test in RStudio, and for that we need to create a new object. Let's call it result1, res1, that will be storing the results of chi-square test. And the same command, and when I want to see, it gives us the same results. That's chi-square test and p-value. Now I want to see what is there in this object. That's a result1 or res1, and I will enter here attributes res1, and it shows me that it has these parameters stored there. P-value is there, method, observed, expected, all these things are there. And as you know that at the core of chi-square test, one of the most important thing is a comparison of actual value with expected one. So we may be interested to see what is in expected value, what are the expected values, and for that we use this one, res1, that's result1 $sign and expected, and it gives us these results, that this is the one that was expected, and the actual one we can check with the one that we computed in Microsoft Excel using pivot function table. So these are our actual values or observed values, which mean, for example, blue and dead, actually they were 7, but expected is about like 124. And gold, dead, those people who were dead and they were wearing gold color uniform, actual is 9, but expected was 49. In any case, this is just more information. The most important thing is chi-square value and critical value. Critical value we had already seen in Microsoft Excel, and p-value, which of course is less than 5, and therefore we reject the null hypothesis.